there are many methods, right, which we can design to distinguish them. So for example, you could collect a set of documents written by humans, which are sure written by humans. You could collect a set of documents written by machines. And then you could train sort of a classifier, a machine learning model to tell the difference. But this kind of method has a limitation, which is, machine learning is sort of limited to the training data. So an algorithm learns how to differentiate human and machines in the training set. But say, suddenly there was a new machine generator that came out, but it's not in the training data. What it generates is not in the training data, so this algorithm will face difficulties in detecting it. In other scenarios, right, so suppose that there's a new domain, like we created a new scientific discipline, or if the training data doesn't contain biomedical text, but then someone used the machine to generate a paper, like in the biomedical domain, then your machine learning detector will not be able to detect it because it's trained using whatever data has been prepared. This is one line of work. So a better line of work says, okay, maybe we could make use of some inherent characteristics of the machine generator, right? So to detect what it generates. So this is called unsupervised approach or zero-shot approach. So for example, someone has devised an algorithm that can detect what a known algorithm generates. By what a known algorithm generates, I mean, say if we want to detect what ChatGPT generates, then we first study ChatGPT. We're going to have the model. And how do we detect what it generates? When an algorithm generates a sentence, it actually does a sampling process. So it generates word by word from left to right. And when it generates every word, it sort of uses like a neural network to score all possible words, right? So you rank the vocabulary. And when you generate the word, you try to select the most probable word. So that's the process. Or people might have known the term next token prediction, so which is sort of a pre-training paradigm, and which is also the paradigm it generates a sentence. To say if over the internet there was some training sentence like Westlake University is based in Hangzhou, right? So the algorithm is trained to predict Hangzhou given the previous words, right? And after it's being trained over a lot of data, it sort of learns world knowledge, it learns syntax, semantics, it could generate things. So when you use this algorithm to generate a paragraph or a text, it does the same. It just tries to fill gap one after another from left to right. And then when it generates every word, it tries to rank the vocabulary according to the token probabilities. And it has to sample more probable words. Okay. The reason it does that is because it has no confidence on whether these less probable words are brilliant words or unusual words which are perfectly correct but brilliant, or they are hallucination or incorrect things, right? So it doesn't have a mechanism to decide that because everything it does is based on probabilities. Now back to the detector, right? If you got a model and you got a sentence, you want to detect whether the sentence is generated by the model, then sort of an easy thing you can do is to feed the sentence into the model and then check the probability of the sentence, right? And then you can change the sentence a little bit, okay? Maybe tweak a word or change a small phrase to make the sentence slightly different but still correct. And then you put the new sentence into the model again. And then the model will have to choose more probable words when it generates the sentence. So those tweaked versions has to be less probable according to the model. But if it's written by a human, then maybe it's different, right? The model might give it a lower probability, but human might think that this is a good sentence. Yeah. So this is an unsupervised method. It does very well on a known model, but it sort of cannot quite generalized. So like there is a supervised method, right? So which could like decide whatever the training data can separate. There's an unsupervised method sort of which can decide a particular model, whether the sentence written by a particular model or human. Then this method is not general either, because in the end of the day, you want to detect any model. So how do you solve this dilemma? So our method is sort of course, it's an unsupervised method as well, but we want to be accurate in the open domain. So how do we do that? The method is sort of based on the inherent difference between the model generation process and the human writing process. You know, a model is trained to do next token prediction over the internet, right? So it learns the probabilities of tokens based on a large set of human written data, or no matter whether it's human written or machine written, but on a large set of data over the internet. Okay, so it will minimize the probabilistic or statistical risk over this set of data. In other words, it will calculate the probabilities according to the training set. But when we write sentences, we decide which words to use based on what we really want to say. Maybe when we write a sentence, we choose a token which is very less probable according to the internet, because this is a rare word, but this fits very well with the context to express our meaning. So we will choose this word. So that is an inherent difference between human written sentences and machine generated sentences. Machines, they will choose the safe word. By safe, I mean according to statistics. Okay, this word is frequent under this context, so we'll choose this safe word. But when human decides which word to use, we might use some surprising word to express ourselves. Okay, so based on this difference, right, we could use an algorithm, okay, to measure the probabilities of words in a given document. And then according to these probabilities, if there are no surprises, then this document is more likely to be machine written. Okay, this document will be more likely to conform to the statistical distribution over the whole internet. You would think about it like this. But if we find some very surprising word here and there, then it's very likely to be human written. So this is the basic principle of our method. It turns out to work very well. For example, we could use a very small model to determine whether some text is written by ChatGPT or DeepSeek. But when we use a larger model, the accuracy is better. They're certainly going to improve. There are many areas where large language models could improve. For example, scaling law. So people have found, in particular OpenAI, found that when you increase the size of the data, the size of the model, the size of the computation time, the amount of computation time, the amount of inference time, or the training time, the intelligence will increase. But there's also suspicion on whether the scaling law will sustain, because on the data side, we almost exhausted like the internet. If you look at the scaling curve, definitely the rate of increase will diminish in the end, right? So otherwise, machine intelligence will go out of the universe, right? Yeah. There are other areas for LLMs. For example, multi-modality. Originally, it was trained for handling languages. Are we able to integrate vision and speech and touch and all the other senses into it so that we can build a robot? So this is an ongoing research area. And there is some fundamental research to think about. Whether the current neural network architecture can handle them, or do we need some new paradigm, right? So there are also other things like what I mentioned. Can we inject some human cognitive parts into the current deep learning mechanism so that it could reason better, or fundamentally it could do better things than the mechanical next token prediction? So there are other researchers who mention similar things like system 1 and system 2 in human mind. So one is for intuition, one is for logical mathematical reasoning. So there are other researchers mentioning a world model. For humans, right, we have an understanding of things in the world. So, and we could do things according to the guidance of this world model. And we have some guidance on what we expect things to happen before we make decisions, rather than just choosing some more probable things. These are other directions of improvements. So I think in terms of AGI, we're definitely much better than before. But I don't think the real AGI will happen very soon. So this is my personal understanding. Maybe I'm wrong, but from my understanding of these technologies, I think we still need some breakthrough in the fundamental side of AI research for that to happen. Yeah. So of course, that depends on your definition of AGI, right? As I mentioned earlier, there are already a lot of things AI can do which humans cannot do. And there are still things humans can do and AI cannot do. So my AGI is, okay, AI can do pretty much everything human can do.